Okay, now we're going to talk about some proofs, and traditionally proofs were done in two-column form, statements and reasons, or even a flow proof, but now with new Common Core language and procedure, we're going to try to prove congruence through a series of rigid motions or through a series of transformations. Now you can see these two triangles that are given here at the top. We're trying to prove that those are in fact congruent. Even though we already have a side-angle-side relationship marked, we're going to prove why that side-angle-side relationship works through a series of rigid motions. Now it's important to get comfortable not working on an XY axis or in a coordinate grid, because a lot of times with these Common Core rigid motion relationships we are not going to have any coordinates or grid. We'll be working on just plain white paper. Now the first thing I'm going to do is call this point here A prime, because it's my second triangle, and this point here the original A. And what I'm going to do is translate this prime triangle along this vector from A prime to A. Now that results in this second picture here where A and A prime are this point right there. Now to make this a little bit easier to explain, I'm going to name some other points. I'm going to call that B prime and its corresponding point on the other triangle B. That will make it easier to describe my next step, which is going to be rotate the bottom triangle about point A such that B prime maps onto B, which would result in this third triangle, or this third set of triangles over here. Now if it hadn't jumped out at you yet, you can see that we have a nice line of reflection now along line segment BA. And if we reflect the bottom triangle along vector line segment BA, it will map perfectly onto the top triangle, thus proving congruence, thus showing that side angle side does work for proving triangles congruent through a series of rigid motions.